so this is your test review for Unit 8. There are two parts of your review, a calculator portion and a no calculator portion. Start with the calculator portion. This is to review solving square root functions. So we'll just do a couple, I think, let's see, we'll do 3 of the solving ones. Hopefully you're good at these because this is the lesson that you just finished. All right, in order to solve this equation, you're going to isolate the square root. So to start here, you're going to subtract 1 from both sides. We'll get 2 square root of x over 3 equals 8. The square root is still not isolated. I need to divide by 2. Get the square root of x over 3 equals 4. Now that you're isolated, you can square both sides. Okay, so I'll have x over 3 equals 16. And then you multiply by 3. 16 times 3 is 48. Now you have to check. Now there's a box here that you can check your work. My suggestion is just to type things into Desmos. Right? So I'm going to take that 48 and I'm going to type it into Desmos, put it where the x is, and see if they're equal. So what I have is 2 times the square root of 48 divided by 3, and then plus 1 outside the radical. That equals 9, which is what my original equation equaled. So I know 48 is my solution. All right, part D on the next page here. I'm going to do D and E. For D, I have the square root of a whole quadratic here. So since the square root's isolated, I'm going to square both sides and get 2x squared minus 5x minus 12. Now that's already set equal to 0. There's no GCF. I have to split the middle and factor to find our roots. 2 times negative 12 is negative 24. Two numbers that multiply to negative 24 and add to negative 5, negative 83. So I split my middle. And then I group. Right, I'm going quickly through the factoring because you should know how to factor at this point. If you don't, you need to see your teacher. But you passed the factoring unit if you're at this point in the course, so you should be okay there. All right, now that I have factored form, I set each of those factors equal to 0 and solve for x. I get one root at 4 and one root at negative 3 over 2. So I have to check my work. What I'm going to do is I'm going to graph this in, so I don't have to type all that stuff in multiple times. I'm going to graph the original 2 equations and then see if those are where my graphs intersect. So I'm going to start here with the square root of 2x squared minus 5x minus 12. That's my first graph, and I want to know where that equals 0. Well, it looks like I have positive 4, which was 1, and negative 1.5. Well, negative 1.5 is what negative 3 over 2 is equal to. So since those intersect at those 2 points, those are actually both solutions. Right, and I just use Desmos to check. All right, last one for the calculator allowed is E. I'm going to start by squaring both sides. I'll get x squared plus 40 equals negative 7 squared is positive 49. I'm going to subtract 49 from both sides. Actually, yeah, I can do that. Okay, x squared minus 9 equals 0. And this one I can solve 2 ways. So here I'm going to factor this one, the difference of squares. And get the solutions of 3 and negative 3. Now I have to check on Desmos. So I'm going to start again by graphing this in Desmos. So I have the original function, which is the square root of x squared plus 40. And I want to know where that equals 7. Oh, negative 7. You know, when I look at this, it looks like those lines are nowhere near each other. So this actually has no solutions. They don't intersect. So these are both extraneous. Means there's no solution, which is your empty set. All right, that's the calculator portion. You can only use your calculator on that part of the test. Then you'll get an other sheet that's no calculator allowed. We'll start here with a domain problem. It says which of the following for number 3 is the domain and range of the function 5 times the square root of 2x plus 8. Remember, when I find the domain without a calculator, algebraically, I take the radicand, what's under the radical, and set it greater than or equal to 0. Here I'm going to solve for x. I'm going to subtract 8, get 2x, greater than or equal to negative 8, and divide by 2. Here it says x is greater than or equal to negative 4. Now I have to match that to one of these problems. Negative 4 here. I want greater than or equal to, so that means including negative 4 and all the numbers bigger. My interval notation would start at negative 4 and go to infinity. So I can eliminate b and d. It looks like a and d are both my domains matched. And I have to talk about the range. Range, think about your graph. I know there's no picture here, but think about the transformations that have happened. This 5 is a vertical stretch. Makes the graph taller, but it doesn't move it up or down. So my graph is going to be tall, it's not moved up or down. We don't know what the 2 does, but the plus 8 on the inside just moves my graph left and right. So I know I'm kind of at positive, means I'm going to go to the left here. But it doesn't look like there's anything on the outside right here with a plus or a minus. So my graph doesn't move up or down, which means the range is starting at the y-axis of 0, which is why D is going to be your correct answer. It's a little bit more complicated, but you have to understand transformations and how to find domain. All right, number 6. We are determining the domain. So again, just like that last problem, we're finding the domain and writing it in set builder notation. So you take your radicand and set it greater than or equal to 0. I'm going to subtract 6 from both sides and divide by 5. That gives me x is greater than or equal to negative 6 over 5. Now to write that in set builder notation, that's your curly brackets. And all that says is that our domain are the x's such that all those x's are greater than or equal to negative 6 over 5. And that's how you would write set builder notation for that domain. Number 7, multi-step graphing. All right, I have a parent function, transformations here. So I look at my graph. The minus 3 on the inside means that my graph is going to move right 3. And then the plus 1 means that my graph moves up 1. This only has 2 transformations, so I don't need the third graph. All right, now moving to the right means I'm going to take this point at 0 and just move it to 3. And each of these points, I can just keep following the pattern. I'm going to move them all right 3. Those are the only ones that are going to fit on my graph. So that's where I start. Then I take each of those points and move them up 1. There we go. There would be my picture. And my domain here goes left to right. So on the left, my farthest to the left x is at 3. And my arrow on the right means I go towards infinity. My range has the lowest y value at 1, and it also goes up to infinity. All right, let's look at another one. I have part C here. So for this graph, I have a 3 in front, which means that my graph has a vertical stretch by 3. The negative under the square root means that my graph is reflecting over the y-axis, and the minus 7 means my graph went down 7. Let's start with the vertical stretch. You need to know the y values of each of these points. So I multiply each y value by that vertical stretch of 3. 0 times 3 is 0. 1 times 3 is 3, so my point's at 1, 3. 2 times 3 is 6, so I'm at 4, 6. 3 times 3 is 9. So my vertical stretch makes that square root graph look really tall. To reflect over the y-axis, you have to know where the y-axis is. That's the up and down one. So I'm just going to flip my graph over that axis. The points all stay the same otherwise. Negative 1, 3, negative 4, 6, negative 9, 9. Go. And then down 7 is simple. You take each point and just move it down 7 units. So 0, negative 7, 1, negative 4, 4, negative 4, negative 1, and then 9, 2. That would be a graph. So my domain starts on the left. I have an arrow on the left, which means my domain goes from negative infinity up to the x value of 0, inclusive. The range is on the bottom. I start at negative 7, and my graph goes up, has an arrow, to infinity. All right, now I'm giving you a graph. We have to state the transformations and write the equation. Now, if you need to draw the parent function here, so that you can compare. Right now, our graph, it looks like it went up, right? It went up 5. It didn't go left or right. It does look shorter, compressed. So normally I go up 1, out 1. Here I go up 1, I can't tell how far out I go. So let's try the next point. I went out 4, up 2. So this time I went out 4, up 1. 1 is half of 2, so I have a vertical compression by a half. When I write my equation, that vertical compression goes outside the radical. The up 5 goes on the outside. So it'll be 1/2 square root of x plus 5. All right, number 9. Finally, last two, we're going to write the equations given the situation, or the transformations. Vertical compression, that's on the outside, the 1/4. Reflecting over the y-axis is underneath the radical in front of the x, and up 6 units will be a plus 6 on the end. For the next graph, when I reflect over the x-axis, that's a negative in front. Vertical stretch by 3 also goes in front, and left goes under the radical, and it's a plus 1. So that would be your equation. Try the other problems on the review. See if you have questions, check the key, or ask your teacher for help if you need more help.